So in our last example, we have an application of how we can use three equations and three variables to solve a problem. So here we have tickets to the Auckland Girls Water Polo games are priced at $75, $55, and $30 were kind of a big deal, so hence the inflated prices. And then we've got some more information about the how many tickets were sold, how much we brought in revenue, and so on. But the first thing we've got to do is we've got to define three variables. So we did this with our two variable system, so we want to establish what are our variables going to represent. So for part A, I'm going to say that X is going to be the number of front row bleacher tickets that are sold. Y is going to represent the number of regular bleacher seats, and then Z is going to be the number of standing room only tickets. So we're not talking about the price here, we're just talking about the number of tickets. So how many of each of those were sold. So those are going to be our three variables. And so now we're going to use the information that's here to build our three equations for part B. So to start off with, we're told that 230 tickets were sold. So we can stop right there, and that's enough information for us to piece together our first equation. Because if X, Y, and Z are all representing the number of each of those types of tickets, and then we have 230 total tickets were sold, so that means our first equation could just be X plus Y plus Z equals 230. So there's one equation. Then we're going to factor in the information here about the total amount of money that was generated. So we collected a total of $8,700. Well, to figure out how much we collected from each type of ticket, that's where these costs are going to come in. So if I know that I sold X bleacher front row seats and they cost $75 a piece, that means the amount of money that I'm going to collect in those front row tickets is going to be 75 times X, $75 times the number of tickets we sold. I'm going to do the same thing for the Y, so it's going to be 55 times Y, so $55 a seat times the number of seats, and then finally plus 30 times Z for the standing room only tickets. And so then together that adds up to make the amount of money that we raised, which was $8,700. Then we need one more equation. So that's where this last sentence comes in. So it says 3 times as many bleacher tickets as front row tickets were sold. So we have to be careful here to make sure that we understand which one there was more of. Was there more front row tickets, or was there more bleacher tickets? So it says if 3 times as many regular bleacher tickets as front row tickets were sold. So that means our front row tickets is X. We're going to put that on the opposite side of the equation as Y. So it says there's 3 times as many of those bleacher tickets as front row tickets. So that means I need to triple the front row ticket amount to equal that amount of regular bleacher seats. 3 times as many regular bleachers, that's Y, as there were of the other types. That can be a confusing thing to try to read through. So again, just think about which one is there more of. So whatever there's less of is the one that you're going to have to multiply by that 3. So in this case now we've got our three equations, our three variables, but unlike our previous examples, we're actually going to be able to use some substitution here to help us out. And so what I'm going to do is I'm going to take advantage of the fact that I've got Y is equal to 3X. So what I'm going to do is in each of these equations where I see Y, I'm going to substitute in 3X. And so then that top equation will be X, I'll write it over here, plus, in place of Y, I'm going to put 3X plus Z equals 230. And so as you can see, let's clean that up a little bit. As you can see, even though we have X plus 3X, I only have two variables. I have X and I have Z. And then if I do the same thing on the next one, I'm going to have 75X plus, and then it's going to be 55 times, instead of Y, I'm going to put 3X, and then plus, that was a 30Z equals 8,700. And so here we've succeeded in going from three equations with three variables through a substitution step to getting to two equations and two variables. So I'm going to clean these equations up a little bit. So this first one here, x plus 3x, I need to gather that up to make 4x plus z equals 230. And then for the bottom equation, I've got 75x plus 3 times 55, so that's 165. So I've got 75 plus 165. If we push buttons on our calculator, or if we just add that up in our heads, we get 240. If I carry the one more time, hopefully we see we get 240. So we've got 240x plus the 30z equals 8700. So now we've got our two equations cleaned up. So now we're ready to decide, do we want to use substitution or do we want to use elimination? And I'd say, why not use substitution? We've already done it once. Let's do it again. So in this equation here, I can get z by itself pretty easily by just subtracting 4x from both sides. So we're going to end up with z equals 230 minus 4x. And so now I can go to the bottom equation and take this 230 minus 4x, and I can drop it in right there. So I'm going to keep on going here. So we've got 240x plus 30 times, and now I'm going to replace that z with 230 minus 4x right here, equals 8700. And so now we've gotten to a place where we have just one equation with only one variable. Still got a little work to do, but the finish line is in sight. So I'm going to scroll, give ourselves a little bit more room. So we've got 240x. I have a little distributive property. So I've got 30 times 270, or sorry, 30 times 230, which equals 6,900. And then minus 30 times 4x is minus 120x. And then I still have my 8,700. So if I keep going, I've got like terms to gather. 240x minus 120x equals 120x. And then I still have that plus 6,900 equals 8,700. Now I'm going to subtract 6,900 from both sides. And so now we're left with 120x, if I just write it to the side here, equals 8,700 minus 6,900 is 1,800. And so then our last step is to divide both sides by 120. And so then we get 15. So that means there were 15 of these front row bleacher seats sold. We're asked to find how many standing room only tickets were sold, so we eventually need to figure out what Z is, but we're going to have to figure out what Y is first. So I'm going to go right here, and so I've got 3x equals Y, so I've got Y is going to be equal to 3 times 15, so that's 45, and so then my easiest pathway is to come up here to this equation, and then I can say 15 for x plus 45 for y plus z has to equal 230. And so then 15 plus 45 is 60 60 plus z equals 230. And so then my last step is to subtract 60 from both sides, and we end up with z equals 170. So that means there were 170 SRO, standing room only, tickets sold. So here's an example of how we can use a system of equations with 3 variables and 3 equations to solve a problem. But this time we were able to use substitution quite a bit in our pathway to solving. So realize we ended up all over the place, but hopefully you were able to follow that without too much trouble.